Okay, these are some solutions to problems that were assigned for homework. These are problems that are specifically from assignment 22. Additionally, there is an extra problem at the end that I gave in class to some of you so that you could practice. So these are problems that you can expect to see on the quiz. These problems are all projectiles that are launched horizontally. And so that means we can assume that if I look at the x and y direction, ax is 0, ay negative 9.8, v1x, something we don't know or we'd have to be given, v1y in all of these cases will always be 0 because things are being launched horizontally. Other things to be interested in is the change in x, delta dx, delta dy, time. So this problem says you took a running leap off of, this is number 55, you took a running leap off of a high dive platform. You were running at 2.8 meters per second and hit the water 2.6 seconds later. How high was the platform and how far from the edge of the platform did you hit the water? So this has somebody running this way, traveling at 2.8 meters per second, and we know that it takes 2.6 seconds to land. So 2.6 seconds, and that is true for both the x and the y. It takes as long to go forward as it does to fall. The horizontal velocity is 2.8 meters per second, and we want to know delta y and delta d. I'm actually going to do this problem as two separate problems. I'm going to look at the x. So in the x direction, I know the relationship between delta dx, v1x plus 1/2 at squared. Remember that acceleration is 0 in the x direction. The velocity is 2.8 meters per second. And there's 2.6 seconds to move. So delta dy is 7.28 meters. So that's the horizontal displacement. In the y direction, we're going to do the same thing. The values are different, but it's the same method. So I'm going to use the same equation, except remembering this time I'm only using y quantities. So v1y is 0 because this is a horizontally launched situation. The person is only running horizontally when they leave the platform. Acceleration is negative 9.8 because we're looking at the vertical motion. And again, time is 2.6 seconds. When I calculate dy, got 33 meters, and it should be negative because we're falling down. By the way, that's an absurd height for a diving board. I think internationally, high dives are about 10 meters high. So that's number 55. So now number 58 is a situation where you have an airplane traveling at a certain height horizontally and it wants to drop supplies. Again, I'm going to use a table to sort out x and y. Ax is 0, ay is negative 9.8, same as always. This is a horizontally launched situation, so v1y will be 0. v1x is something we know in this case. We can then look at delta dy, delta dx,